Yeah, coming to analog inputs to the PLCs, there are three types will be there. One we call two-wire system and three-wire system and four-wire system. Today we are going to explain about how these inputs are going to scale in the delta PLC, right? In that cases, first of all, we need to decide that what type of input we have. What type of input we have is the matter here. Okay, let's say for example, if you have any transmitter or kind of it is a two-wire means. First of all, plus minus will be there for every two-wire systems. The options we call it as the plus minus, it is there already. Okay, here the minus is the signal. Okay, whatever the signal we need to connect to the analog signal to the PLC itself. Okay, okay, in these two wires, one is the power wiring, one is the signal wiring. Which is the power wiring, which is the signal wiring, that details we need to collect from the supplier itself only. Okay, and let's say most of the cases are minus is the signal here for any two wire system. It is okay, minus is the common kind of here. Okay, minus is the signal that we need to give to the signal to the PLC itself. Okay, coming to the transmitter, second one is power, right? That power we should give it to the 24 plus itself. Okay, and then the next is the right 24 minus, that we need to connect in the PLC itself. In the PLC we have minus option is there na? For that minus we need to connect the 24 minus itself. Okay, if you have three wire systems, if you have three wire kind of, in that cases how we need to connect it is the thing. But three wire system is having, two is the power, one is the signal we need to connect to the signal. Power plus minus is there na? Power plus 24 plus we need to give, 24 minus we need to give to the PLC itself. Whatever the signal is there na, that we need to connect to the, coming to three wire communications. It is coming to three wire, plus minus is the power supply we need to give, signal is the signal we need to give the signal to the PLC itself. 24 plus minus is there, right? In that 24 plus minus we need to give power to the PLC itself. 24 plus 24 minus we need to give to the transmitter, whatever the transmitter we use. Okay, and signal, based on the signal itself we should connect it is, if the signal is plus means you should connect here minus. The signal is plus is oriented coming, you should give minus here. Here whatever the signal is coming in, that opposite we need to give here. Okay, coming to the analog input, four wire communications. Okay, in that four wire, three are the power itself ma. Three are the power, one is the signal. Two signals will be there, two signals. In that two signals also, one is the signal, one is the power itself. But plus minus is then 24 plus we need to give to the 24 plus 24 minus to the transmitter itself. Whatever the signals are there, right? In that signals also, one wire is the signal, one wire is the power. Okay, whatever the signal and wire, everything he is going to mention in their catalogs itself. Okay, according to that you need to go through the links, right? Okay, now I'm going to discuss about the delta, what we have the model is there, how we need to connect our transmitter to the PLC itself. Let's say for example, I'm going to design it as soon as possible. Here I'm going to take the module here itself, 04 DVP 04 ADES is the model number of the drive itself. Okay, in that cases minor drive, not drive, it is extension module. Okay, it is having the four channels. In that I'm going to take a transmitter here. The transmitter, before that whatever the RTD is there na, that I am going to design here. Let's say assume this is the RTD itself. Okay, in this RTD, this is RTD I'm going to take it as, one second. RTD, it is an RTD. RTD is having three wires, right? Okay, three wires, you need to take the three wires. Okay, from the three wires itself we need to connect, I'm going to connect this thing to the transmitter itself. This is the transmitter. Okay, this transmitter is having 5 terminals, 5 terminals itself, 5 terminals. That terminal I'm going to represent like circle itself. Okay, RTD that we need to connect to here. Here also RTD 3 wires will come, right? That we need to connect to the RTD input side. Whatever the output side is nothing but output side we have 3 is there. Okay, what are those is nothing but one is the here one we call it as the one is plus is there here. One is plus. This is the let us in this is the plus. Okay. The next one is the minus. Okay. Here next coming to our PLCs. The PLC extension module is there. Huh? Okay. In this extension module also. In this extension module, the extension module is having if you search in the Google also 04AD E2 DVP 04AD. Okay, this is an extension model. What we have exactly into that case. So if you have side, then it is useful to apart from all this is the good. Okay, I will connect here itself. See that we need to connect to the going to enter into the PPT here. Lively I can connect to you, and this is just for the reference itself. Okay, if we closely observe here, we have for every channel is having 4 terminals. What are those is nothing but this is analog output model. What are those is nothing but the terminals is having the terminals 4 terminals will be available in that. What are those is nothing but here the 24 plus will come, 24 minus. When you connect it like this 24 plus, this is 24 plus, 24 plus, minus. If you connect like this, then only this is going to enable all the analog modules power supplies. Okay, we have to give it. We have to give it to the PLCs. Okay, next we have again 4 terminals are available. 4 terminals. In that we are using 2 terminals only. Okay, what are those terminals is nothing but V4 plus 4 channel I am going to give it V4 plus. Okay, then next I4 plus. external is I4 plus I4 plus external VI minus VI4 minus VI4 minus. Okay, these are the terminals. Okay, in this case, how we need to connect this transmitter to the power is the matter, right? In this case, we need to loop the V4 and I4 itself. V4 and I4 plus we need to be. Okay, I4 obviously it is the current signal, right? Here also same with the transmitter will give you 4 to 20 milliamps from here. Okay, 4 to 20 milliamps. This signal, which is the signal is nothing but this is the signal here. Okay, this is the signal here. That signal we have to connect this signal to the as usual signal to it. One second. Signal to the signal itself. Okay. There is a signal that I am giving. And then I'm going to increase this line also. Okay. Signal we need to connect to the signal itself. Next, we need to loop this one and this one. We need to loop this one also. And we have to loop this I4 and V4. Okay. V4 I4 we need to loop this. V4 I4 we need to loop this. Okay. And 24 plus we need to connect to the 24 itself. This is the 24, which is the power is nothing but here. This is the power. Okay, here we need to connect the 24 plus itself. This is how we need to give the 24 plus we are doing, right? Here we need to give the 24 minus itself. 24 minus. This 24 minus we need to give it to the second. This is how wiring of the transmitters, RTD transmitters with the module itself. Module is having the 3 terminals. In that 4 to 20 milliamps. First of all, RTD is going to give certain signal to the transmitter itself. This is the transmitter. RTD transmitter it is. The transmitter is having the 5 terminals. In that, first 3 are the RTD transmitter, right? Transmitters. Okay. And the next, after that, in this RT terminal, one is the signal, which is the signal. Here the signal is, this minus is the signal that we need to connect to the minus of the, that we need to give the current signal to the PLC extension 1. These two we need to loop it. This is mandatory for the current type of signal to the PLC. Okay. After that, okay, VI4 itself. Therefore, we need to connect to the 24 minus. Okay, like that. This is the wiring how we need to connect the wave transmitters kind. Okay, and I have connected all the wirings of relevant on that. Okay, just I'm going to go through the communication how we need to do. First of all, I'm going to take the backup from it. Okay, for that I need to use the communication cable itself. Through that communication cable, we need to upload and download a program. Upload and downloading a program itself. 1 second, I'm going to search it. Yes. Here I'm using a RS232 communication cable. This is an RS232. This is an RS232 communication cable that we need to connect here itself. Okay, for that, I want to give this one to the system itself. That system also backside I'm giving. Okay. After that, we need to do the communication transfer setup from PLC to PC. I'm taking the backup from it because I did already. Even if you observe here, I have connected the 1 second. I'm going to stop the screen share. In this, I have connected already. This is an extension model. Okay, this is main CPU. Then these are all extension model. This is RTD. This transmitter I told, right? RTD transmitter is having 5 terminals. That is also I have connected to the PLC itself. Okay, like that. First of all, we have connected all the wires and all. Okay, now we are going to do the communication kind. How we do scaling of a PLC in the particularly Delta PLC. Okay, before going to that, 1 second. Where it is settings and settings to change it. Right, done. Next, communication transfer setup from PLC to PC. I have taken the backup from it. Okay, now this is the backup what we have in the PLC itself. Okay, and then next, okay, I did already the wiring kind of, right. 1 second. Yeah, we have connected already RT transmitters and all. Okay, how we have taken this 2 value for that 2 K0 K5, what these are all will come in the mind, right? 2 is nothing but, let's say for example, delta manual. If you open the delta manual kind here, first of all, this is first extension, right? This is first extension, right? In this first extension, that's why we have taken here K0. Okay, what is this K5? K5 is not okay. We have connected that one. Okay, in that case, each and every channel we have connected for the channel 4, right? This is the channel 4. For this channel 4, what is the CR number here? 5 is that is the K5 we have mentioned. Okay, in that which channel? Okay, which module it is the first one? Which channel right now? Right now it is the fourth channel. Fourth channel CR number is K5. In that case, which input we have given? 4 to 20 milliamps we have given, right? 4 to 20 milliamps we have given. Okay, 4 to 20 milliamps we have given. Okay, like that, we need to take the two value here. K1 is the like additional bit. It is just run the model. We are taking the K1 itself. What is this D1 D9903? If you open the manual of the this 04AD module, in that case, if you go to the scroll down, each and every channel is having their own, right? Yeah, let's say for example, if you have connected module 0 for the channel 4 model, we have connected module 0. In that channel is D9903. All the values is going to store in the D9903. Okay. Such a way we need to take the 9903 value. Okay, we are getting the maximum 33,000 kind of value we are getting, right? For that we need to take the scaling. This is the raw value meter, right? That for that we need to take the a scaling kind of here. How we need to take the scaling? But we need to divide this D15. I have moved the D9903 for the D15 itself. From division, we are going to divide this D15 to the K100 it is. Okay, let's see what will happen in that. And then it is going to store in the D16 itself. Okay, I'm going to delete it. Let's say come to the compile itself and transfer setup, and then PC to PLC. We have to communicate it. Okay, if you open that value kind of here, and again it has divided into that. Oh, that divided value same here. One second. We need to divide it DAV D15 with K100 D15 with K100 with K100 into the D16. Kindly communicate this PC to PLC. Now it has communicated. Okay, we go to the online. D15 has divided here, and exactly we are not getting right. We need to get here K116 is getting, right? But which is the 32767 by 300 we need to take by 300. Then we are getting the exactly the 100 degree centigrade. Okay. -39 degree centigrade is there. That we need to vary it. One second, we need to take the matchbox here itself. Matchbox is I'm going to vary this temperature. Okay, I'm going to vary this temperature with this one. Okay, see here, degree centigrade is going to increase. Okay, now how this while using these temperatures and all, how our drive is going to vary the speed is the matter here, right? That we can plan it. Why? Because PLC drive will take 2000 is for the 20 edges. Maximum it is 50 edges only, right? D 15. All is going to store in the value of, it is GH2001, it is going to store, right? In that case, all this is speed set value. Speed set value. D11 is the speed set value. Okay. In that case, take this one, same thing. Divide it. D15. Divide this one by exactly. I'm going to decide that it is exactly 35,000 is the maximum value coming for the scaling, right? 35,000. I'm going to consider it. Okay. Let's say, for example, we can calculate first of all. This new slides. 35,000 maximum value is 35,000. Okay, 35,000. Okay, but we need this one for the 50 hedges. 50 hedges. For 50 hedges, we are getting this one. We need to 35,000. This is the maximum value. What is the one value here? What is the, let's say, for example, what is the one value? One hedges, how much it is? For one hedges, question mark, right? 35,000 by 50. 35,000 by 50. Calculator. 35,000 by 50. 35,000 divided by 35,000 divided by 50. Each hedge is 700, right? We need to divide this value by the 50. By the 50. We need to divide it. Divide this D15 with the K50. And then move on to the D11. These all are going to store in the value. Certain D16. Let's take the D17. Okay. Next, take the move contact. Whatever the move, right? Move this D17 into D11. Speed. Okay. Compile it and transfer it to the PLC itself. Now drive is running, right? I'm going to vary the speed of the monitors. Drive is right. Okay. Go to the online itself. Okay. D17 is having D11 as we have certain value, right? 2000 something is there. 2000 something, it is coming 221. We can turn on it first of all. Drive. Drive is going to vary with the D10, right? I'm going to start this one. Then drive has started, right? And it have the value, certain value it have already, which is nothing but like 219 we have. To go through the value of this one is also from frequency, it is 2.1 is that. Okay. But exactly scaling is not going on. 1 second, I'm going to change these categories into that. Move this K50 is there, na? Like 2 hedges it is coming. Take here 5. We need 5. Take this 5. Compile. Go to communication. PC to PLC. See here, 2020 hedges is coming. You observe here. Okay. If you vary this one, small variation also. If you vary this one, say for example, drive is running on 20 hedges of this things, right? If I increase it, small increase also, value is increasing. Okay. If you vary the temperature, automatically hedges is also going to vary that. See here, 25, 25 is coming. Okay. Here also say, it will show you here, 30 hedges is on. Here also same 30 hedges. Like that, we need to scaling of a here completely shows that the here we have essential model with scaling process. Through the scaling process, well, you vary the speed of this one, then automatically drive is going to vary the speed. There is the conclusion of this class interest. And one more thing, you need potentiometer wiring also, right? For that purpose, first of all, we need to change it for on off purpose and all. Everything we need to change, and we need to give the wiring to that one also, wiring to the PLC itself, PLC to not drive itself. Okay, one second, I'm going to give the wiring here. I'm going to stop this one first of all. Stop this right now. Okay, I should stop here and take one potentiometer. Take one potentiometer and give the Y to the drive itself. Second. In the potentiometer is also having 0, 10 and certain value, right? 0, 10 certain value. 0, 10 we need to give the 0 for the 0, 10 is for the 10 volts. The signal we need to give for the first case. See here. I'm going to take one potentiometer. Okay. That potentiometer wiring we need to connect to the drive itself. 0, 10 we can connect anywhere, not a problem. But here it should be, this is current type. Now we need to change into voltage type and give the 10 volts for the, this is 10, this is 10. Okay, now I'm going to connect this potentiometer. This is one potentiometer. Okay, this potentiometer is having three terminals, 0, 10 and signal. Okay, 10 I have connected to the 10. Ground we need to connect to the ground. Middle one we need to connect to the signal AV1 itself. AV 1. Okay, if you want to enable this thing, first of all, check the drive, turn on the drive. Check first of all the PPT and all. 1 second. Course those communications. Okay. To open the disk case here, in this 2-00, okay, 2-00, we need to give here 0 to 10 volts. This entry, go to that, back it 2-00, we need to give here how much it is, 2, 1 it is. We need to give the 1. Through potentiometer means 1 we need to check, right? Because 0 to 10 volts signal we need to give, right? Next, form for the 2-01 itself also same thing. For 2-01 we need to give again here the same thing, by external we need to give it. External is nothing but external keypad on off. Keypad. I'm going to take the keypad on off itself. Okay. Now it is going to vary based on this speed itself, right? When I'm going to vary this speed, potentiometer itself, it is going to vary. I'm going to vary this one now. Okay. Even if I vary this, speed increasing. This is speed decreasing. Okay. Like that, we can increase and decrease the speed of the motors. Okay. Hope you understood, right? We can close the section of our classes on that. Okay. If you have any doubts and clarification, just message to me. You can clarify. Okay. Thank you.